So what is marginal distribution? So here in this case, so I'll use the same example again. Okay. So earlier we had individual probabilities and we calculated the joint, the combined probability of both the variables. So I had individual probabilities, I found out, and then I multiplied both to find the joint distribution, probability distributions. And now if I say that you have only the joint probability distributions, and now you want to find the individual probability of one variable. Say for example, if I have this joint, all these are joint distributions for different combinations of A and B, red and blue, being drawn in different terms. So if I have got only these values, I don't have these things. Okay, if I have only this, so let me rub this off. For example, I have only these values. Only joint probabilities are given to me. And this information is provided. And if I ask you that, now how do we calculate the probability of only this, that a red ball is drawn in the first draw? What is probability that I have drawn a red ball in the first draw? So I have the combined probability, joint probability of both, and now I want to find out what is the probability of only one random variable. We modeled this as two random variables. So given that we have two random variables and we know the joint distribution, I want to find the probability of only one random variable. How do we find that? So the given thing is we have the joint distribution, the value. Okay, that distribution we have. So how do we find that? So the marginal distribution gives me that value. So let me formally write it. So what does this mean? Marginal distribution means that probability distribution of an individual. It gives me, what does it give me? It gives me the probability distribution of an individual random variable in a joint distribution. Okay, that is without considering the outcomes of other variable. Here in this example, so if I have to ask, this is given that in this, if you consider only this, that in the first draw I got a red ball. What is the probability of that? I got these values. Okay, so the probability of getting a red ball in the first draw and the red ball in second draw is 6 by 25, and the probability of drawing a red ball in the first draw and a blue ball in the second draw is 4 by 25. Now if I ask you what is the given this information, I have only this information, what is the probability of getting a red ball in the first draw? You have this information, the information in this cell. How do we do that? So this is simple. So we say that without considering the outcome of a variable. In joint distribution, say for example, we have PA and B. This comma is A. So generally this is PA into PB. And we have this value. Okay, this is some value. Okay, some value is there. We have got this. Now, if I want to find only the probability of A, how do I get it? If I have this value, this is, I know this. Sorry, this is known. This is some value X, say. So if I know this combined value, can I say that PA is equal to some value? This is just for intuition, don't take it literally. Okay, X by PB. If I want to find PA, this is what I want to find, the probability of a red in the first draw. So what if, so one way is either we know PB, we don't know that. We know only the joint distribution, we have only the combined value. Okay, we know only this value, but we don't know this. So what if we make this PB is equal to 1? If I make this P of B is equal to 1, then will I get this value, whatever is the value? How do I make this PB is equal to 1? And whatever is the value after that, then that will be there. So it's just for intuition, don't take it literally. So this is what I'm trying to explain, that without considering the outcomes of the other variable. Without considering the outcomes of the other variable means that the other variable doesn't exist. Or even if it exists, the probability of having that is always 1. So if that is there, and if I have the product joint distribution of both of them, if the other one is 1, if I make this 1 somehow, that I consider all the possible outcomes of this variable, then the probability of this will become 1. So whatever value I'll get will be the probability of A. This is what marginal distribution intuitively means, that if I want to find the probability distribution of A, then I sum up the joint distribution over all the possibilities of the other variable, and this will sum up to 1. And because of that, finally what will happen is that whatever value we'll get out of the joint distribution, that will be my marginal distribution of the variable A. I hope that is clear. So let's do this in this example itself. Okay. So here I told you, right? So my given thing is that I know all these values. Now I want to find what is the probability of drawing a red ball in the first draw. So for getting this, I have to make the B as 1. So what are the two possibilities of B? These two. If I sum these two up 1, these two values, so will this become 1 now? So all the probabilities are covered here, of B is covered here. So if I sum this up, will I get the probability of B? So what is the sum here? This is the sum is there. Let me use a different color. For example, this is 6 by 25 plus 4 by 25. This is equal to 10 by 25 or 2 by 5. Can I say this is probability of A? 2 by 5. Let the probability of drawing, okay, what were the balls here? Let me draw it back. So earlier there were 2 red balls here, 3 red balls here, and 3 blue balls here, and 2 blue balls here. So without considering the outcomes of the other variable means summing that up to 1. So if I don't consider what I am getting in the second draw, does that mean that probability of getting a red ball in the first draw, means probability of drawing a red ball from the first bag, is 2 by 5? And isn't this what we have got it here? If I sum up these two values, 6 by 25 plus 4 by 25, is this not the same? So this is what it means, that I have got the joint probabilities, I sum it up across all the possible values of the other variable. That's what it means, that I don't consider the other variable. Means that is always present and its probability is 1. And how do I make the probability of the other variable 1? By summing it up across all the probabilities, all the possible outcomes of the other variable. Okay, I hope this is clear. So let me write it down for you. Just a minute. So this here, so let me write it down here also. Then this is here P of A, and here if I draw one more line, then this will be your P of B. Similarly, I can find all the other probabilities also. So what will be the probability of B here now? So getting a red ball in the second draw, sum it up this way. What will be the value? That will be equal to 9 by 25 plus 6 by 25. This is equal to 15 by 25. Okay, so let's check. So getting a red ball in the second row is equal to 3 by 5. So getting a red ball in the second row is 3 by 5. Similarly, this is 4 by 25 plus 6 by 25. This is equal to 10 by 25. This is equal to 2 by 5. What does this mean? That probability of getting a blue ball in the second draw, B is for the second draw, right? A and B for outcomes of the first and second draw respectively, second bag respectively. So getting probability of B here in this second case means getting a blue in the second draw. So this is 2 by 5. This is what it's giving, 2 by 5. These all values are the, and similarly let's write down here also what will be the value here. So for example, this will be 9 by 25 from here plus 6 by 25. This is equal to 15 by 25. This is equal to 3 by 5. So what does this mean? That getting a blue ball in the first draw or first bag. So this is your 3 blue balls in the first bag. So all these values, that is sum, we have kept the other one as constant or summed it up across all the possible values. So other probability of the second variable becomes 1. So whatever remains is the first variable only. And these all sections here, these are giving you the, this is your marginal probability of A. Here it is marginal probability of B. With this, I think this should be pretty much clear. What is marginal probability? Now let's move. Let's write down the formula and it will formalize it more clearly. So I'll cover all the scenarios again. So what will be the marginal CDF? How do we denote it? So you're familiar with the notations. So this is, so we know that what is the joint CDF? We know this joint CDF is f of x comma y comma is and this is, again I'll write it as a b1 only. P of x less than equal to a and y less than equal to b. This is what it is, summation of all the values till a till b. Such that minus infinity is less than ab. So these values lie between minus infinity and plus infinity. Okay, so what will be the marginal CDF from here? CDF is cumulative distribution function. What will be the marginal CDF? This is of CDF. So this will be of x. So now marginal, this was for both of them, x and y. Sorry. So joint is for both x and y. Marginal will be for only one variable. So let me write of x. So this will be only f of x. And if I say that, so in this thing, that how will we denote it? So a comma, if I said the other one is infinity, so this is, it will be minus infinity to a. This less than equal to a means all the values less than equal to from minus. So if I give it minus infinity, this starts from minus infinity to a. So if I give it infinity for b, it gives minus infinity to infinity. Does this not cover all the range, all the possible values of y? Means whatever is the probability here, this will sum up to 1. It will give all the possible values of y. So we write that as infinity, that it will give me all the possible values of y from minus infinity to infinity. That's how make the other one as other variable as 1. We don't consider that. So this will be equal to probability of x less than or equal to a and y less than infinity, means all the possible outcomes, covers all possible outcomes, whatever is there of y, it will give, and it will sum up to 1 because all the values will lie between minus infinity to infinity only, right? Whatever is the value. Okay, and this comes up as, how do we write it? This is equal to probability of x less than or equal to a. Okay, so similarly, what will be the discrete case? Discrete case, countable case. What will be the f of x of a for single value. Here you see that it was x comma y. This is only for single variable. Given that we have and y less than infinity is equal to summation. So from the joint one, xi less than equal to a, and this will be, what will be the value for y? So y of j belongs to R, the complete real number. This means minus infinity to infinity. So this is a short form of that. It belongs to R, the complete real number range. And same thing, x is equal to xi, comma, y is equal to yj. This is your discrete case. I hope this is clear. Next one, continuous case. So these are all symbols or notations, symbols, okay? So that you get familiar with these notations. And maths is nothing but symbols, right? So get comfortable. So this is, while I'm writing it, I'm telling also in the English interpretation of that too. So what will be the capital F is always CDF, okay? This capital F is CDF, again f of x is CDF. What will be the value? Similar thing, x less than equal to a, comma, y less than infinity. This is equal to x will range from here, and y will be the complete range, minus infinity to infinity, and then we will have the joint PDF, and we'll integrate it over the complete dy dx range, and this will be so equal to minus infinity to infinity f of xy x comma y, and we'll integrate it over dy, as I mentioned earlier. Note this dy, that for finding the value of x, we integrate it over the other variable. You have seen it here, right? For finding the marginal probability of a, I am summing it over the other variable. Here also, for finding the variable for x, I am summing up over all the y outcomes. That's what it means. From here we have understood this clearly. So for whatever variable we want to know the marginal probability, is sum up the, or sum it up over all the possible values of the other variable, okay? And what do we sum up? The joint probability or the joint distribution what we have. So this is your CDF of marginal probability distribution. Now let me formalize the this thing also, marginal PMF. Here I'll tell you one more thing. How do we derive it? Okay. So say my joint distribution is given by, this is for the discrete case, okay, is equal to probability of x comma y, comma is always read as and, is equal to probability of x is equal to x comma y is equal to y. This is my joint probability, okay? So we have learned the law of total probability earlier, I hope remember, when we were doing conditional probability. So let me explain you again with the help of that. So we have the joint probability. So how did we do that in case of two variables? So here, for example, all the possible values. So let me draw the. So this is an intuitive understanding. So this is my sample space. This is my omega sample space. Okay, and say these are my possible values of this is my y1, y2, y3, so on till yn. So these are all my possible values of y. Okay, and then we have our, this is the joint distribution. This is my joint distribution. So remember, the complete sample space is divided by all the possible values of y. Okay, the complete sample space is divided into multiple, okay, mutually exclusive partitions by all the possible values of y, and this is my joint probability distribution. So if I find the intersection of this with all the possible values of y. This will give me the total probability of the other variable. So if I do the intersection of the joint distribution with respect to the other variable, or the summation over other variable, so I'll get the joint distribution, the marginal distribution for finding the marginal distribution of x. We'll have to do this. And what are the from the law of, this is from law of total probability. So just divide this. Probably I'll put the link of that video also in this, just to explain you law of total probability again. Okay, so what are the probabilities, what are the properties of this? That y is equal to y1 intersection y is equal to y2, these are mutually exclusive, so this will be equal to a phi null set, and the sum of all this should cover the sample space. So y1 union y2 union till yn should be my omega. So these are the two conditions that it should satisfy, and this is my joint probability. And if I sum this joint distribution probability across all the possible values of y, I'll get the marginal distribution of x. Let me write it down as a note. So marginal probability, so here x is equal to summing up the joint distribution across all the possible values of other variable, in this case y. Okay, so I hope this is clear. This should be, by now it should be very amply clear what is marginal distribution. So do you want one more example here? So let me give you a practical example. So let me give you the setup, quick setup. Okay, setup. So I'll roll a die. Okay, setup is roll a die, fair die, plus flip a coin or toss a coin. So I'm doing two things. Okay, plus toss a coin. So I'm capturing this or modeling this using two random variables. This is x is roll a die. Okay, so what will be my sample space? 1, 2 till 6, and y will be toss a coin. So what will be my sample space? Heads and tails. Okay, so now if I, what will be the joint PMF? Joint PMF of both of the events happening, x comma y, will be equal to 1 by 6 into 1 by 2. So 1, 2, 3, 4, 6, out of that one possibility, and head or tail one possibility will be equal to 1 by 12. This is my joint PMF. Okay, and now if I want to find the marginal PMF of x from this also, one more simple example. Marginal PMF of x. So this will be equal to Px of x, probability of x, okay, x, okay, equal to summation of y belongs to, what is the possible values, head comma tail, that is two values, and probability of x comma y, xy. This is equal to, what is the summation for head and tail? For head it is 1 by 12. This is the joint probability, right? This is 1 by 12. I'll sum it over all the possible values of y. So this is my combined joint probability PMF, and then for head 1 by 12 plus tail 1 by 12, this will give me 1 by 6. This is what is your, this is your probability of rolling a die. So if you are given this thing, from that I can take out what is the probability, marginal probability of just two variables. This is the combined joint one, and from that I can compute the single variables PMF. Okay, I hope this is amply clear now. And let me write the formula also. With this is clear. So marginal other formula for the continuous case. Quickly, let me write that down. So what will be the marginal PDF like? So let me write down the formula for you so that you remember. So this we have seen the notations already. Okay, we have seen the notations already. Let me write it down for you. So single variable f of x, small f for probability distribution function. Okay, this is minus infinity to infinity given f of x comma y. This is my joint PDF. Okay, and then integrate it over y. This is for x, integrate over sum over the other variable. Okay, and this is your joint PDF. Simple. I hope marginal distribution is clear now.